Why when your friends grab you?
It's really a whole story. I think if you were there, you would understand.
I have 5.
It's fine. You put them in your notebook for later. Okay. Are you guys ready?
Yeah.
So, what's that?
How many cars?
Just one. So, give her a zero line. Is that cool?
Are we done?
Yeah, you can wait or you can draw along with me. Either way is fine. But we have our zero line, and what we're going to do is we're going to try to reconstruct like the Buggy Lab with some specifics that go along with it. And then we're going to see how a couple things relate. Are you ready?
Yes.
So we're going to start looking at our buggy. Okay? But our buggy doesn't start at the zero line. The buggy is, when we start counting, it's already out in front of the zero line. Is that cool? So when we start counting, our buggy is out in front of the zero line. Is that okay? And it's moving to the right at a speed of 40 centimeters per second. It's moving to the right at a speed of 40 centimeters per second. And when we start looking at it, it's 30 centimeters to the right of the zero line. How's that look? Does that seem reasonable to you guys? What's that, Dylan?
I was just making sure it was centimeters.
Yeah. So it's really just like the Buggy Lab. What we're going to do here is we're going to try to figure out where our buggy is. And we're just going to go every second. Can someone give me a forever statement for this 40 centimeters per second?
Every 40 centimeters.
Actually, start with the bottom. So start with a 1. So for every...
Second moves
Go, Trestle.
30. Oh, Proverbs 2. Okay, I remember, I know.
Go ahead, Roy.
For every second, it moves 40 centimeters.
Good. So for every additional second, it moves an additional 40 centimeters. So what I'm going to do is I'm going to draw a data table here. Okay? So this is position time data table. So time 0, 1, 2, 3, 4, 5 seconds. Is that cool? You guys with me there? What are the positions of the car? What are the positions of my buggy? What is the position at time 0?
30.
30 is 100% correct. Because when we start looking at it, it's already at 30. What is the position of the car at time 1 second? It's 70. How do you know it's 70? Because for every additional second, it goes an additional 40. Where was it a moment ago? It was at 30, so now it's at 70. What about at 2 seconds?
I can count that high.
Where is it at 2 seconds? 110?
Yeah.
You sure? How'd you get 110?
70 plus 40.
Because for every additional second, it travels an additional 40 centimeters. What about the next one? 150?
190.
190, and then 230. How's that sound?
Great.
You guys with me? This is why the forever statement is such a big deal, is because it tells you how to construct your data tables. All right, let's draw the graph and see if we can get a position time graph of this. So we need 1, 2, 3, 4, 5 seconds. This is time in seconds. This is the position measured in centimeters. Is that cool? So where's our guy? At 0 time, where is he? 30. Then 70. Then 110. Then 150. 190. And 230. Do you expect it? Did you expect it that it was a straight line?
Yeah.
Sure. Does that look okay? Not too bad, right? And this is just a rehash of what we did the other day. How far did the buggy travel in the 5 seconds? Check with your neighbor now. How far did the buggy travel in his 5 seconds? Check your neighbor now. There's not a lot of neighbor checking. I mean, you should talk to your neighbor. Say, hey neighbor, how are you? How far do you think the buggy traveled?
Yeah, travel 2 seconds to do, let's start at 30. 200. Start at 230.
You might have to read. It's something that's in the
Jaden, did you check your neighbor?
I did, yeah.
What did your neighbor say?
230.
He said
Oh, I mean,
230?
200. He said 200.
200 or 230?
200.
This is a legit question. Is it 200 or is it 230?
It's 200.
You think it's 200 or 230?
200.
200. But it says 230 right here.
It started at 30.
You guys hear what Jaden's saying? I think he's right here. So, one of the ways that we look at this, okay, is we say if I started at 30, I ended at 230, what's the difference between those two? 200. That's one way to do that. And to do this, we call this, you guys remember what the triangle means from yesterday? The triangle means change. So the change in the position, and remember it's always final minus initial. What's the final position? 230 minus 30. So the change in the position is equal to 200 centimeters. Is that cool? There's another place to see it on here. There's another place to see it on here, which actually I think is even cooler, is if you look over here on this, I'm going to do a little circle around the initial position. What's the initial position? It's 30, correct? With me on that? And then at 5 seconds, what's the final position?
200.
The final position is 230, right? And so if you look at the difference between these two, is that the change in the position? Is that 200? You guys with me on this? So this change in position will tell you how far it went. Okay, the change in position will tell you how far it went. Now, I told you yesterday that oftentimes we don't write position, sometimes we just write X for position. And so sometimes you'll see change in position, but if you see this symbol also, this is the same thing. So this literally means the change in the position, but we use X for position, which I know is confusing, but notation's a thing. Is that cool? All right. That's all from the other day. Let me show you what's new about this. What we're going to do now is we're going to draw the velocity versus time.
Is this supposed to be on the same papers?
It can be, or it could be in a different one. Whatever you want to do. I don't care how you take notes.
Okay.
It's all for you. This is just notes because if you want to have these, because you want to reference them later, because remember, all the assessments are just whatever you created, you're using. So I want you to have an opportunity. If I'm going to draw something, you can draw it too. All right. How many seconds at a time? 1, 2, 3, 4, 5 seconds at a time? What does the velocity versus time graph look like for this buggy? Check your neighbor now. What should the velocity versus time graph for this buggy look like? Check your neighbor now.
Yeah.
All right. What should the velocity time graph look like? What's that?
I didn't make it.
Okay.
It's gonna be a straight line.
Like this? This line's straight.
Well.
Horizontal straight.
Or, yeah,
Horizontal?
180 degree.
So flat line.
Yeah.
Where?
Like if you.
Above the,
Up here?
positive.
How far up?
At 30. You have to,
At 30? It's definitely horizontal. I will agree with you on that. But we want to know what is the value right there. Okay? Check with your neighbor, see if your neighbor knows. What is the value? How high up is it? Okay?
it's 40. Probably at 40.
Should be
I just can't do that.
Still be
Poor Larry. I feel for that kid.
I'm sure some.
What's hard is, I don't know the extent to which his ability to get here rests on him. Right?
Yeah.
You know what I mean? Like, if you're coming from, if you're coming from a distance away that is, really hard to get here, and you're relying on somebody else to drive you, it can be hard. All right. What's the value? I also think it's 40. Where's the 40 come from? What does this say right here?
40.
40 centimeters per second. Is that the slope of this line? It is, right? Is that the velocity of the buggy? Yes, it is. So this value right here is 40. Because that tells you how fast the car is going, and because it's positive, it tells you the car is moving to the right. Okay? Feel okay with that so far? Here comes the cool part. Does this graph tell me how far the buggy went? That's a real question.
No.
No.
What does this graph tell me?
Oh, wait.
Velocity in a given amount of time.
This graph tells me how fast the buggy's going. True? But does it also tell me how far the buggy went? It's kind of sneaky. You're going to have to look for it. All right? Watch what I'm going to do here. If I come over here, okay? If I come over here, and I'm going to say at 1 second, I'm going to come up here, and I'm going to drop a vertical down here. And I look at this area here. First of all, what shape did I create? Is that a rectangle?
Or 2 squares.
Okay.
You write it?
Well, it's a rectangle. I think we know how to find the area of a rectangle. Do you know how to find the area of a rectangle? How do you find the area of a rectangle?
Based on height.
It's the base times the height. How's that sound? Is that cool? So, what is the base here?
1
1 what?
second.
It's 1 second. And what is the height there?
40.
40 centimeters.
No.
It's not 40 centimeters, it's 40 something. What are the units there?
Centimeters per second.
What's that say?
40 centimeters per second? What is that showing me here? Now, as a quick aside, you learned something in math that I don't think is 100% accurate, but I'm going to write it down anyway. Okay? I don't like it, but it's going to be useful for us here. What is 4 divided by 4?
1.
Okay, it's 1. Is that cool? Okay? If you have